Hello friends, now I'm going to solve a problem which is considered to be the best problem on moment of inertia forever by experts of JEE. Here is the problem. From a solid sphere of mass m and radius r, a cube of maximum possible volume is cut. Moment of inertia of a cube about an axis passing through its center and perpendicular to one of its faces is. Here is a problem in which we are having a solid sphere of mass m and radius r, from which a cube of maximum possible volume is cut. We need to find the moment of inertia of that cube about an axis which is passing through its center and which is perpendicular to one of its faces. So let's draw a rough diagram of this. Let this be the sphere from which we need to cut a cube of maximum possible volume. Let this be cube which must have maximum possible volume. The cube will have maximum possible volume when the diagonal of that cube is equal to the diameter of the sphere. So the cube will have maximum volume when its diagonal is equal to the diameter of the sphere. So diameter of the sphere is 2r and the diagonal of this cube is root 3 into some a, where a is the edge of the cube. The formula of diagonal of a cube is root 3a. We know that. So 2r is equal to root 3a. Now, mass of the solid sphere is m. We need to find the mass of the cube in order to find its moment of inertia. Always remember that this is a very important point which you need to remember, and that is moment of inertia of a cube in which the axis, let it be any axis, but it must pass through the center of the cube. Passing through its center is m a square by 6. Here a is the edge of the cube. A is edge of the cube. Always, this is very important point to remember, that moment of inertia of a cube in which the axis is passing to the center, let it be any, no matter how the axis will be, but it must pass through the center. Then the moment of inertia is ma square by 6, where a is the edge. So where here m is the mass of the cube. And next, let density of the sphere be p. Then density, we know that density is equal to mass by volume. So what is the mass of the sphere? M. So mass by volume. We know the formula of the volume of the sphere, which is 4/3 pi r cube, where r is the radius of the sphere. So now this is also the density of the cube, because we cut that cube from that sphere. So this is also the density of the cube. Now what is the mass of the cube? Mass of the cube is its volume multiplied by its density. What is the volume of the cube? Volume of the cube is edge cube. So a cube. Here we assume that a is the edge of the cube. So a cube into density m by 4/3 pi r cube is the mass of the cube. So here, substituting the value of a, here a we implies by from this equation we get that a is equal to 2 by root 3 r. So substituting this value in this equation we get 8 by 3 root 3 r cube multiplied by 3 by 4 into m by pi r cube is the mass of the cube. So this 3 cancels 3, r cube cancels r cube, and 4 2s are 8. So the value is